All right, today we are going to be looking at section 1.1, getting started in the book. So if you would, I want you to either look in the glossary or find these in the chapter, starting on page 6, and fill in the definitions for variable, algebraic expression, and evaluating expressions. I'm going to pause my video and give you a chance to look those up, explore and see where these are in the chapter, where they are in the glossary. Refresh yourself. You should know these definitions. But get them written down, and then we'll talk about them real quick. All right, so if you take a look, a variable we talk about all the time in middle school, a letter or other symbol that can be replaced by a number, so such as X, but we've also talked about it can be any letter. An algebraic expression. So an expression is anything like this, adding, subtracting, a whole bunch of different operations going on. It's kind of like a number sentence, but it includes one or more variables. So looking down at these examples, these would not be an algebraic expression because there's no variables. If you look down to example 2, these have variables. Okay, so these would be algebraic expressions. These would be numerical expressions because they just have numbers. And then evaluating an expression is basically getting the answer. So it's the process of finding the numerical value, so the number that represents the expression. And it's basically simplifying following your order of operations. All right, so for example number 1, this is going to kind of look like the review we did on Friday. Just real quick, following your order of operations, we're going to remember that it's parentheses, then exponents, multiply and divide, add and subtract. That's 4 steps. Multiplying and dividing happen at the same time. Adding and subtracting happen at the same time. So when I look at 36 minus 3 times 4, the main thing I need to focus on here is make sure that I don't do the subtraction and then multiply. Multiply comes first. So the first thing I'm going to do is the 3 times the 4, which is going to give me 12. Bring down 36. And I'm going to work straight down. 36 minus 12 is 24. So when I look at the directions that say evaluate each expression, it basically means to simplify using order of operations. All right, example number 2 in here. Parentheses comes first. So I see this exponent, and sometimes people want to do 10 to the second, but parentheses always comes first. So everything inside of parentheses needs to get taken care of before I do anything else. So 6 plus 10 becomes 16. I'm just going to show that that's still inside parentheses. It doesn't have to. You could drop the parentheses at that point. And then 16 squared, you can do it in your calculator. 16 times 16 is 256. Just make sure that you're not doing 16 times 2. It's 16 squared, so 16 times itself. And the third example, parentheses first. So 4 minus 2 is an operation inside parentheses. I need to take care of it. I know it's up there in the exponent, but it's still an operation inside parentheses. So I'm going to leave the 6 alone. 4 minus 2 is 2. I'm going to bring everything else down. Now this 15 has parentheses around it, but those are just showing you that this is multiplication. There's no operation to do inside. So those don't come first. So now that I've eliminated parentheses, step 2 is exponents. So 6 squared is 36. Again, 6 times 6. And next step would be multiplication. So I'm not going to add 2 and then multiply. I'm going to multiply first. So 2 times 15 is 30. And now last but not least, I can add, and I get 66. All right, so those would be numerical expressions. There's no variables. When they say evaluate the expression, it basically means simplify and find the one number or the numerical value of the expression. So going down to example 2 now, we're going to evaluate some algebraic expressions, and they tell you that a is equal to 5. If you don't know what that is, if they don't tell you what a is equal to, you're not going to be able to evaluate these. So we're just going to replace a with the value and then simplify. So in this case, a is being raised to the second power, so 5 is going to be raised to the second power, and then multiplied by 3. Now notice over here, there's parentheses. This entire expression is being raised to the second power. In this one, since there's no parentheses, only a is being raised to the second power. So this says 3 times, I'm going to replace a with 5, and a is being squared, so 5 must be squared. Following my order of operations, exponents comes first. So I'm not going to multiply anything right now. I'm just squaring the 5. And again, the 3 is not being squared because there's no parentheses to tell me that, just the a. So I'm going to leave the 3 alone. 5 squared, 5 times 5 is 25. And 25 times 3 now is 75. But if I look at this next one, it looks very similar. Okay, but these parentheses have definitely changed the order that I'm going to do things. Parentheses always comes first. If there's an operation to do on the inside of parentheses, you got to do it first. So there's multiplication here. So inside parentheses, it's going to say 3 times 5. And that whole quantity is being raised to the second power. So because of these parentheses, I have to multiply here first. So 15 is being raised to the second power. 15 squared is 225. 15 times 15. Again, use your calculator. But you can see just adding parentheses has drastically changed the value of my answer here. Okay, so it's very important to understand what the parentheses do and what happens when they're not there. Last one. So if you see this 3a squared, that's going to end up being 75. We're going to show the work, and then we're adding 4. So let's see if we can follow this through. So this says 3 times a squared, so 5 squared, plus 4. Multiplication, exponents, addition. So exponents comes first. So it's 3 times 25 plus 4, very similar to what we have here. Now I have multiplication and addition. So multiplication comes first. 3 times 25, 75 plus 4. And you finish it off and it's 79. All right, continuing on. Example number 3. I do want to show you in the book that you can find many of the examples that we're going to do together also in the book. So if you look at the bottom of page 8, example 2, you will find the exact problem that we're doing right now. Okay, and they'll talk you through it in the book as well. So just want you to see a lot of these examples are directly from the book that we're doing here. All right, so we're going to evaluate this. So simplify it down to just one number. They tell you n is 21 and w is 0.5. So we're going to replace the variables with the numbers and simplify. So starting with the top of this, it's 6.8 minus w to the third. So w is 0.5, so 0.5 to the third power. On the bottom, n minus w, n's 21, minus w, 0.5. All right, so we need to solve the top. We need to solve the bottom. The last thing we're going to do here is divide. So on the bottom, we can kind of just do it. 20 minus 0.5, you take a half off of 21. Or think about you have $21 and you pay 50 cents. 0.5 is like 50 cents off of that. You have $20.50, so 20.5. On top, we've got two operations. We've got to do the exponents first. So we're going to leave 6.8 alone. And we're going to do 0.5 to the third power. You can do this in your calculator. 0.5 times 0.5 times 0.5. Or use your exponent button. So if you have one of these calculators, you can just do 0.5 raised to the third power. And there's your answer, 0.125. Notice on this one, it's kind of easier to work left to right as opposed to down. So when you have one of these fractions that you've got to solve a lot on the top and get a quantity on the bottom and then divide, sometimes it is easier to work left to right. So now we're going to subtract on the top, 6.8 minus 0.125, and we're going to get 6.675, and I still have 20.5 on the bottom. Now, if I want to fully simplify this, I need to divide here. So I'm going to do 6.675 divided by 20.5 in my calculator. And this is the result. Okay, that's not a nice decimal. So at this point, I could round if the directions told me to, but since it didn't tell me to round, I'm just going to simply write down that entire answer, and that's perfectly fine. So it is 0.325609756, and that is a perfectly acceptable answer here in this class.